Welcome to the video. In this video we are about to run a quantum AI SDK in Google Colab. So we'll just directly go to the documentation of that quantum AI SDK. This link will be in the description. So what is this quantum AI SDK? This is qrl-qai, and it is a framework focused on quantum reinforcement learning. It's built on top of Gymnasium, which is the extension of the Gym framework by OpenAI. So this is pre-ChatGPT era thing, right? Then comes Penny which is Penny is a quantum computing SDK, right? It's more popular for quantum AI. And then PyTorch, I don't have to introduce PyTorch to you. Now on the left sidebar, if you see, there's a bunch of different sections available. So the first is installation, and this is a pip installable framework, so you can just do pip install qrl-qai and the framework will be installed, right? So this is the installation and the quick start guide for you, then the tutorials on the algorithms, the value iteration, q value iteration, the different environments that this particular quantum AI SDK offers, that tries to cover different aspects of quantum computing, like compilation, error, noise, and expressibility, all the different aspects of quantum computing. But let's look at the home page. If you see, there are different versions that the SDK has had, and the latest version 1.0.0 offers a Google Colab and an associated Lightning AI Studio. So Lightning AI Studio is allows you to experiment with this framework without any sort of coding. So it sort of offers you a no code experience, right? So in just a Streamlit UI, you can play with the different parameters and experiment with different environments it offers and the different algorithms it offers, right? And this is more for non-tech people that we'll cover in the next video. But in this one, let's directly jump on the Google Colab and see what it looks like, right? Okay, so this is what the Google Colab looks like, and it tells you right away that changes will not be saved. You do not have permissions to save this notebook. To keep your changes, make a copy of this notebook. So let's go ahead and do that. I'll save a copy in Drive, right, so I can make changes and play around with it. Meanwhile, let's just have a look at this. So it's installation, algorithms. Okay, the notebook copy is done. Let's open it. Okay, it's still going on. Okay, done. So the first comes the installation, then the 2 algorithms it offers in this version, and 6 environments, right? Let me just connect this first so we can get it and start programming. So the installation, as I told you, it's pretty straightforward. It's pip install qrl-qai, and then the version, which is 1.0.0, right? Once this connects, we'll just hit the run and allow it to run. Okay, the Colab has connected, so I can run this cell. Let's allow it to run while we can explore the rest of the stuff. So the first heading is algorithms, and it has a bunch of different stuff. Okay, all right. So first is the value iteration. It's a reinforcement learning algorithm, and it has described all the theory here. So what is reinforcement learning algorithm, this, and how it works, all the math and stuff. Here it defines the constructor, so how this particular SDK offers this algorithm, the API documentation basically, and the different parameters, the type, what are different values, what's the description, then the different methods that this class has, because it has been implemented as a class, right? So the different methods and what a typical training loop would look like in this algorithm. And then comes the Frozen Lake V1. So Frozen Lake V1 is a very popular reinforcement learning environment, which was created by the Gym by OpenAI, right? and if just think of it like a fashion MNIST or MNIST of reinforcement learning, right? Okay, so again, so it's basically an environment of 8 by 8 grid, and you have to go from one starting point to a final end point, and then there's all holes in it. So if you fall in it, the agent dies basically, right? So the algorithm, the value iteration algorithm, helps the agent or the program to navigate the entire environment successfully. That's the goal of it. You can see the installation process is still going on, so we can't run it, but yeah, let's look at this. So this is the entire training loop. You can see the entire outputs are still kept. You can get the policy, so what the model actually learned. You can see the policy here, right, which direction to go. It's been kept here. Okay, then the example 2. So the value iteration now on Blocksphere v1, which is a qrl-qai environment, right? So now we are entering the the quantum domain, and now if you see, it again describes the entire environment. So models a single qubit Blocksphere as a deterministic finite graph. It has 6 states, so these are all quantum computing states. These are basically vectors, right? And then you have 4 actions. So again, these are matrices that performs actions on the qubit. Reward, and it's either 1 on reaching the target state or 0 otherwise. It sort of mimics frozen lake, right? And left panel, right panel. Okay, so this is for the how it looks like when during the generation of the the video. Okay, so again, a lot of different stuff. Now comes the Q value iteration. Okay, the installation is done. Restart. Okay, restart will take a little time, but you can see that the pi-lanes mark was gone now, so it has recognized QRL. Okay, so from qrl.algorithms.classical import value iteration, from qrl.env import Blocksphere1. Let's import it. Let's see what happens. Okay, it's running. I should print all this stuff once the run is done. Okay, yeah, it works. Okay, now let's just try this loop and see what a rendering looks like, right? Okay, it solved it pretty good. If I just run this, greedy policy and the learned value state, nice. If I just go here, as it's been saved, yes, the GIF has been saved. Okay, so this is what it looks like, and I would like you to experiment this yourself on the different environments. Again, if I show you, this is Q value iteration, another algorithm. Okay, the image for Blocksphere v0 is not rendered, so just for this I'll go to the original notebook that's linked in the documentation, because that is the associated images with it. I'll just show you the different environments, and you can just play around with this entire thing, because it's a comprehensive, it's a complete SDK. It's difficult to show the entire thing here in the one video. This is just an introductory video. Okay, this isn't been rendered here either. Okay, that's some news, but yeah, so it's got 6 different environments, and you can see it has got all the different details on it. What's the observation space, rewards, what happens on reset, how the episode ends, what is render. And if I go back here, and if there's link to GitHub here, no, it doesn't provide link to GitHub, but yeah. Okay, if I just go again back here, okay, this is the rendering is still done here of the outputs, so you can see. Okay, yeah, this is what a Blocksphere looks like, right? Similarly, if I go to the other environments, I can just show you the environments. compiler, no, yeah, the compiler looks something like this. And the next comes is the error channel. So this is for the trying to correct the error, right? The bit flip error. It's quantum computing. If you don't understand, it's all right. And this is what the rendering looks like. Now expressibility, this is a cool one. So this is the circuit architecture, and this is what it looks like. Again, this is on all quantum computing. Probability V0, this one is actually the coolest one. And what the goal here is that this you have this target distribution, and your goal is to match the predicted distribution to the target distribution. And you can see the model has sort of done that, right? And it has learned over time. And again, this integrates with AnyLane and QML.gradient descent optimizer, right? And yeah, so that's pretty much it for the Google Colab, and I hope this is a good intro. This is the beginning of a series, so I'll introduce the Lightning AI Studio in the next one. And then, as environments come up, the new releases come up, the new videos will keep coming. And even before that, I'll try to create dedicated videos for all the important environments and the important algorithms that are in the Quantum AI SDK. So make sure you subscribe to this channel if you haven't already, and we'll meet you in the next video where I'll show you what you're seeing on your screen, how to create this particular Streamlit app from the Lightning AI Studio. It's all a few clicks, but I'll show that and help you to experiment with these algorithms, which is all text here, but in the Lightning AI Studio it's all visual. You can just play around with the parameters, change algorithms, change environments, and and see all the rendering in real time. So yeah, I think this is already been a long video. I'll see you in the next one.